Hello everyone, welcome to DP Tutorials by Donny Jarwa. In this teaching module, we will solve one numerical problem from chapter 3, which is current electricity, from example 3.9. Now this numerical problem will be pertaining to applications of Wheatstone Bridge principle. So the first thing before solving this principle is that we need to verify whether the bridge is balanced or unbalanced. Like in this particular example, we have to find or we have to determine the current through all the branches or the current through each branch. Okay, and from here we have, or in this network we have different branch. Okay, so we have first of all you have to count the number of resistors. Over here there are altogether 5 resistors connected across all the respective branches. So according to Wheatstone bridge principle, we have this equation, which is P by Q equal R by X. Okay, P by Q, this is the balance condition of Wheatstone bridge principle. P by Q should be equal to R by X. Now if you try to verify this result, now you must have seen, suppose if I take this as a resistor P, I take this as a resistor Q, and I take this as resistance R, and I take this as resistance X. Okay, I take that as resistance X. So the ratio of the opposite arms, okay, first of all, the ratio of these opposite arms should be equal. Okay, so which means that P into X should be equal into R into Q, so that this result will hold true. Now let us try to verify whether this bridge is balanced or not. So if I take only, okay, if I consider only P by Q, okay, if I consider only P by Q, we will get this result. Okay, we will get this result. Suppose like this is P divided by Q. So what is the value of P? P will be how much? From here it will be 10 ohms. And what is the value of Q? The value of Q is 5 ohms. So this will give you the ratio of what? This will give you the ratio of 2:1, which is equal to 2. Now if we take the ratio of R by X, so over here there is R, and over here this is X. Now if you take from this example, what is R? R over here is how much? R is 5, and X is how much? R is 5, and R is 5, and X will be how much? X will be equal to 10. So over here you'll get the ratio of what? The ratio will be equal to 1:2. Yes or no? The ratio will be equal to 1 divided by 2, which from this analysis, okay, we can come to the conclusion that the ratio of P by Q, okay, the ratio of P by Q is not, okay, equal to the ratio of R by X. So if this condition is achievable, then it means that there are some current which will flow. There will be some current which will flow through this 5 ohm resistor. Okay, through this 5 ohm resistor, which means that current will flow through all these resistors. Okay, like in the Wheatstone bridge principle, instead of this 5 ohm resistor, we have what? We have the galvanometer G. Okay, we have the galvanometer G. And according to the Wheatstone bridge principle, it says that this ratio of P by Q should be equal to R by X, such that no current flows across this branch. So the first thing before solving this particular numerical problem is that you need to mark off the junction points. So over here, let us mark the junction points from the bridge. Okay, this will be A, B, C, D, and I have marked this E, and also another junction point will be F. Okay, another junction point will be F. Then the first thing we need to assign is, let us assign current. So this is the cell having EMF 10 volts. So the current will come from this cell having EMF of 10 volts. And there will be one current which flows along this direction. And let us assign that let I1 be the current flowing along the branch FE. Then this current in the main circuit will enters this branch, and this part of the current also will enter this branch, which means that Suppose let I2 be the current flowing across EB branch, and let I3, okay, be the current moving along one. Let this I3 be the current moving along this branch AB. Okay, that will be I3. And there will be part of the current which flows across. There will be part of the current which flows across this 5 ohm resistor. So let us name that current across this branch as 1. Suppose let this current be I4. Okay? Let I4 be the current. Okay? Let I4 be the current. So that will be the current. Okay? I4 is the current flowing across the branch BD, whose resistor is 5 ohm. Then from here you have to apply Kirchoff's current law. So from here, first of all, we will assign this current I1. Okay, we will assign current I2. We will assign a current I3, and we will assign current I4 across those respective branches. Okay, across those respective branches. Then next we will apply KCL. Okay, Kirchoff's current law. We will apply Kirchoff's current law at 1, at junction point B or at point B. So we will apply Kirchoff's law at point B. So when we apply Kirchoff's law at point B, or Kirchoff's current law at point B, that means the current I2 enters point A, whereas current I4 it leaves point B. Current I2 enters point B. Current I2 enters this point B, whereas this current I4, it leaves point B, which means that part of the current will move. You have to find the remaining current. Which flows across what? Across this branch BC. So this will be the current. This will be the remaining current. So what will be that remaining current? So according to Kirchoff's current law, that means the current which flows across the branch BC will be 1. I2 will be taken as negative. So I2 will be taken as positive. This will be taken as positive. And this I4 will be taken as 1. Then I4 will be taken as negative. So the current I2 minus I4, this will be the current which will move along 1. This will be the current which will move along the branch 1 BC. So this will be the current which will move along the branch BC. Okay, so that is the first point. Okay, second point, again we will try to find out. Okay, we will try to find out what will be the, let us mark over here. This will be the current I2 minus I4. Okay, I2 minus I4. So let us find another current which move across this branch. Okay, we also need to find what is the current moving along this branch. We have determined this current, and we will determine this particular current which move across the branch DC. So similarly from here, using the same analogy, that means from here when you look from that diagram, this current, this is the point D, and this current I3, current I3 enters point D, and another current, this current I4 also, it approaches point D. The current I4 also approaches point D. So which means that both these currents will be taken according to the convention, that means it will be taken as positive. So this current which moves across the branch BD will be the addition of I3 and I4. So again applying Kirchoff's current law, at that junction D, okay, applying KCL. So applying KCL at point D. So the current will be I3 plus I4. So this will be the current along, this will be the current along branch DC. So this will be the current along branch DC. So now, so let us write this current over here. This current will be I3 plus I4. And if you want to verify this current, that means the current over here, this current will be I1 again. Okay? This current will be I1 again. Why? Because if you add this, if you add these two currents, okay, if you add these two currents, that means at point C again, at point C, let us try to verify over here. At point C, okay, at point C, if you add those currents, okay, I1 minus I4 from this branch and this I3 plus I4, I3 plus I4 from that branch, this will be equal to 1. This will be equal to I2 plus I3. And what is this I2 plus I3? I2 plus I3 is nothing but I1. Okay, I2 plus I3 is nothing but I1 from Kirchoff's one, from Kirchoff's current law. So which means that at point here, okay, at point here, at that point here, okay, at that point here, the current I1 will be equal to 1. Okay, if you use again Kirchoff's current law, at that point here, that means I1 will be taken as positive, whereas I2 and I3 will be taken as negative because they are moving away from point A, which means that from here it will be negative of I2 minus negative of I3. This will be equal to 1, 0. Then if you try to solve again from here, that means this value of I1 will be equal to 1. I2 plus I3, which I have shown here, okay, which I have shown on this step. Now suppose let us mark this, okay, let us mark this as equation number 1. Okay, let us mark that as equation number 1. Then for finding the currents in the respective branch, okay, we will consider different loops. We will consider on this loop AB, DA, BC, DB, okay, and so on and so forth. So first we will consider on this loop. Okay, let me consider this as the first loop. Okay, this will be the first loop. So on the first loop, you'll find out that we will take point A as the junction point, and if point A is taken as a junction point or the reference point, so I2 will be in the clockwise rotation. This arrowhead will indicate the direction. So I2 will be in the clockwise rotation with respect to A. Even the current I4 across this branch also will be in the clockwise rotation, whereas this current I3 is opposite to this rotation or taken calculation, so it will be in the anti-clockwise direction. It will be in the anti-clockwise direction. So from here, when we write that applying KVL, basically while solving these types of problems, that means we will be engaging to KVL and KCL. So over here we will apply, let us apply Kirchoff's voltage law to that loop. Okay, in some textbook we define this also as well as mesh. Okay, as mesh. Suppose that first loop, which is our ABDA. On that loop ABDA, okay, on that loop ABDA, you'll find out, okay, on that loop ABDA, you'll find out that this current, okay, this current I1, okay, over here this current I2 will be taken as 1. This I2 will be positive, even this I4 also will be positive, whereas this I1 will be negative. Whereas if you take into consideration only on this loop BCDA, there is no cell, so it will be taken as what? It will be taken as 0. So over here, that if we sketch that diagram, it will be in that form. It will be in that form. This is point A, point B, point D, and point E. So over here we have what? We have the 10 ohm resistor. Over here we have the 5 ohm resistor, and over here also we have the 5 ohm resistor. So first current, this will be current I2, this will be current I4, and this will be what current? This current will be sorry, this current will be I3. Okay, this current will be I3. That current will be I3, which means that the clockwise rotation of the current are taken as positive. So which means I2 will be positive and I4 also will be positive. Whereas this I3 is in this direction. So that will be taken as negative. This is the current I3. Whereas in this cell, whereas in this loop, there is no cell. So if there is no cell, so the total EMF of this loop will be equal to 0. So multiply first. You have to multiply. KVL means multiplication of current and resistance. Multiplication of current and resistance. Multiplication of current and resistance. So from here, the first equation will be, let us multiply current and resistance, which means this will be what? I2 into 10, okay, plus the sign over here will be plus, it will be plus, then this will be the current across what branch? AB, then current, then voltage drop across branch BD will be what? Will be plus I4. Why plus I4? Because we have taken as positive with respect to this junction point, clockwise rotation. So this is the clockwise rotation, this will be the anti-clockwise rotation. Then this will be I4 into 1, I4 into 5. Then next will be 1 minus. Why we take I3 as minus? Because it is anti-clockwise. So it will be 1, I3 into 1, I3 into 5. And the total EMF of this loop will be equal to 0. Why 0? Because there is no cell. So from here you have 10 I2 plus 5 I4 minus 5 I3. This will be equal to 0. Now since the coefficients, okay, of this will be equation, okay, linear equation. Now we can divide both sides by 5 to get this type of equation. Okay, when you divide both sides by 5, that means we get this type of equation. It means 5 divided 10 divided by 5 gives you 2, 5 divided by 5 will give you only I4, and over here you get only 1, you get only this equation. That means this will be linear equation. Why I say linear equation? Because the power of all these currents is 1. Then we will carry this I3 this side, so that our objective is to find how much is the value of the respective currents. Okay, so this will be I3. Then on this left hand side we have only this equation. Okay, we have only that equation. So let us mark, okay, this as equation number 2. So this is our second equation. So let us put this equation on the box so that we can use this later on. So we can use this later on. Then this is, okay, I3. Then next we will apply Kirchoff's voltage law in this second loop. Okay, let me consider this as the second loop. Let us consider this as the second loop. B, C, D, B. So this point B will be our reference junction or the junction point. So on that on this loop BCDB, that means this current I2, this current, okay, this current I2 minus I4 will be what? Will be in the clockwise rotation with respect to this given, with respect to this taken direction of calculation. Whereas in this whereas this current I4 on this branch BD will be what? Will be in opposite with respect to this direction. Even this current across this branch also will be in the anti-clockwise direction. So from here we will apply Kirchoff's voltage law on that loop BCDB. Okay, BCDB. Okay. So from here, let us just write, we have to applying Kirchoff's voltage law to loop BCDB. Applying Kirchoff's voltage law to loop BCDB. Let us write this loop. This will be the junction. This will be in that form. This will be BCDB, and from here this will be the taken direction. So we have these currents along this branch. Okay, we have the current along that branch, which will be equal to what? I2 minus I4, and this current across this branch will be what? Will be I4, and the current across this branch, this will be equal to what? This will be equal to I3 plus I4. We have these resistors. Okay, the resistors across this branch BD will be equal to 5 ohms, and the resistor across this branch BC, okay, the resistor across this branch BC, again it will be equal to 5 ohms, and the resistor across this branch DC, this will be equal to 1, this will be equal to 10 ohms. Okay, that will be equal to 10 ohms. So let us try to verify again. Okay, 5 and 10 is correct. So from here, which means that when you look from that circuit diagram, okay, from this diagram, even in this network also there is no cell, since on that taken loop also there is no cell, so the total EMF will be equal to 0. So here total EMF of the cell is 0. Why? Because there is no cell. Then taken from this point, since we have written over here B, that means this point B is what? Starting point or junction point or reference point. So that will be in the clockwise rotation. So from here, I'll just write directly multiply. If you multiply this resistance with this value of current, that means resistance into current, voltage drop across branch BC. So from here, this will be equal to 1, 5. Okay? 5 I2 minus I4. This will be positive. Whereas this I4, okay, this current I2 minus I4, this will be in the clockwise rotation with respect to point B, so that will be taken as positive. Whereas these currents with respect to that point B, whereas these currents, okay, this current I4 and this current I3 minus I4, this will be what? In the anti-clockwise direction with respect to B. So I4 and that current I3 plus I4 will be taken as 1. These currents will be taken as 1. These currents will be taken as negative. So from here, minus 5 into I4. Okay? 5 into I4. And over here also this will be minus. This will be 10. Resistor will be 10. And the current over here, this will be 1. This will be I3 plus I4. Okay? I3 plus I4. I3 plus I4. So that whole problem, this will be equal to 1. This will be equal to 0. So this is the way how to apply Kirchoff's law. The first important step that we need to know is from this step, how to apply Kirchoff's voltage law. Whether what will be the sign of I2, okay, what will be the sign of I4, what will be the sign of I3. Similarly over here, what will be the sign of this current I2 minus I3, what will be the sign of this I4, what will be the sign of this current I2, I3 plus I4. By using these conventions, then you can easily find them out. Okay. Clockwise is taken as positive, anti-clockwise is taken as 1, is taken as negative. So from here, you just need to solve this. Then we have seen from this particular expression, that means we have these terms containing 5. So we can divide both sides by 5. When you divide both sides by 5, that means you'll have this expression of I2 plus I4, then minus, okay, I4 minus over here, if you divide by 5, that means you'll get that expression. and over here this will be equal to 0. Then from here, that means let us break that up. This will be I2. This and this is common. Okay, we have I4 and I4, so this will be I4 and I4. That means it will be 2 I4, and over here this will be twice I3. Plus into minus will give you minus, 2 into I3 will give you 2 I3, minus into plus will give you minus, that will give you 1. That will give you 2 I4. This will be equal to 0. Then further, if you solve from here, that means you'll get this value of current I2. This will be equal to, we have seen that we have this term I4 term. Okay? I4 term is there, I4 term is also there. So minus 2 and minus 2 I4, that means that will give you what? Minus 4 I4. Then this will be minus 2 I3. So that will give us equal to 0. Okay, equal to 0. So from here we will write like in this form I3. So over here this is I2. We will carry all these terms, okay, all these terms to the right hand side. Then that will give us what? That will give us positive values. Positive values. So from here, let us write that equation. So when we write that equation, which means that I2 will be positive, when you carry all these, that means that will be what? This minus 4i4 will be positive. Okay, minus 4i4 will be positive. And this 2i3 also will be what? This 2i3 also will be positive. So that is the expression that we are interested. That means this I2 will be taken in this form. So let us put this equation also in the box, because we have to find values of I1, values of I2, and values of I3, and values of I4. Okay, so this will be, let us express this as in continuation of 2, this will be equation 3. So we have arrived till the stem. Okay, we have arrived till the stem. Then next, let us apply Kirchoff's voltage law. Okay, let us apply Kirchoff's voltage law on this loop. Okay, on this loop. Okay, on this loop A, B, C, E, F, A. Okay, on this loop A, B, C, E, F, A. Apply Kirchoff's voltage law at loop A, B, okay, A, B, C, F, okay, A, B, C, F, A. Okay, A, B, C, F, A. Apply Kirchoff's voltage law on this loop A, B, C, F, A. What do we have? Okay, what do we have? So when you look at that loop A, B, C, F, A, okay, A, B, C, F, A, it is like that. So we have that resistor over here. Okay, we have these resistors over here, and also we have the cell over here, and it is in that form. It is in that form. So from here, this is A, B, C, F, E, A. Okay, A, B, C, F, E, A. There is a slight mistake over here. A, B, C, F, okay, F, E, A, which means this point A is our reference point. Then when you look from that diagram, that means we have a 10 ohm resistor over here. We have the 5 ohm resistor over here. We also have this 10 ohm resistor over here. And this will be the EMF of the cell, which is 10 volt. Which in this loop, if you consider on this loop, there is a cell. Yeah, there is a cell having resistance of 10 volts. So from here, the current across this net branch we have represented as I2. The current across this branch BC, okay, the current across that branch BC will be, when you verify, it will be I2 minus I4. and from here this will be that main current. So the main current from here will be that I1. This main current from here also will be I1. So this current I1 flows, it enters from the negative terminal of the cell to the positive terminal of the cell. So the EMF of the cell will be taken as positive or will be taken as negative. So there will be decrease in voltage. Then from here again this current I1, this will be the main current I1, and that current I1 will move across this 10 ohm resistor. So if we take in this direction, in the clockwise direction, if we take in the clockwise direction, so I2 will be clockwise. Okay, this current I2 minus I4 also will be clockwise. Okay, that current I2 minus I4, this current I2 minus I4 will be clockwise. Even this current I1 which enters to this resistor also will be clockwise. So the product of voltage and current or voltage drop across all these branches will be positive. So with respect to AB, if you write with respect to AB, so it will be 10 into I2. Okay, 10 into I2. I2 is positive. Why? Clockwise. Next, potential drop on branch BC. This current is positive. So you will write plus, then it will be 5 bracket, okay, I2 minus I4. Then from here the current moves, it will enter this cell. The EMF of that cell will be equal to minus, because why? There is a drop in potential if the current flows from the negative terminal of the cell, which is at a low potential, to a high potential. So EMF of the cell will be taken as negative. And then from here this current I1 moves to this 10 ohm resistor. So since the direction of the movement of current with respect to A is positive, is clockwise, so that I1 will be taken as 1. That I1 will be taken as positive. So it will be plus 10 I1. What is this plus 10 I1? This plus 10 I1 will be the current. Plus 10 I1 will be the current across this resistor 10. Then all this will be equal to 0. Okay, so that is the way how to find out the Kirchoff's voltage law with respect to this loop. Okay, so now we will just solve. Over here also we have terms containing 10, so we will divide both sides by 5. If you divide both sides by 5, then you will get this equation. Okay, you will get this equation 2I2. Over here this will be equal to I2 minus I4. From here this will be 1. This will be equal to plus, okay, that will be plus I2 I1 plus 2I1, and over here this will be equal to minus 2, that will be equal to 0. Then the first thing that you need to do over here is that focus all these are terms containing what? Current. And over here what you have to do? Cross multiply, carry this minus 2 to the right hand side, so that you can solve the unknowns. Okay, you can solve the unknowns. So when you carry that 2 to the right hand side, from negative it changes into positive. Okay, so from here this is I2, this is all I2. That means you will get what? You will get the term of 3I2. And then next you have this minus I4. Okay, and then next you have what? Plus 2I1. So that will be one equation. This will be one equation from that loop, from this loop. Okay, from that loop A, B, C, F, E, A. So we will put this also in a box. Okay, this formula we will put in a box so that we can solve the unknown. Yeah. So next part is that we will try to substitute some of the values, okay, some of the values in some of the equations so that we can find the unknown. Like for example, if on this equation I2 or on this equation 3, okay, on this equation 3 we have this factor, which means over here I can put this value of I3, I can use this value of I3 in equation 3 to substitute this value, okay, to substitute that value. So we will do like that. Okay, first of all we will try to substitute to remove some unknowns. So therefore, okay, we will try to use on equation 3. Okay, therefore equation 3 implies, or you can write, okay, let us write using that equation 2. Okay, using equation 2, in equation 3 we have equation 2, in equation 3, okay, we have, what do we have? So this is equation 3. Okay, we want to find, this is I2. So that is I2. And we have 4 I4. On equation, on the second equation, okay, on the second equation we have what? We have this term. Okay. On equation number 2 we have what? It is 2I2, 2I2 plus I4. Okay, 2I2 plus I4. So over here we will put this value of 2I2 plus I4. So it will be easier for us to find out the unknowns. Okay, 2I2 plus I4. So from here, let us try to solve. So from here, this will be 4I4 plus 2 into 2 will give us what? Will give us 4I2. Then from here, this will be 2I4. So from here, again, there are some terms which are like terms. So from here, you will have a term which is 4I2, and over here we have I4 terms and I4 terms, that gives us 6I4. So this will be 1, and this will be the value of 1. This will be the value of I2. So on the right hand side we have I2, I2, okay? I2 and I2. So from here, when we since we have this I2 term on the right hand side, if we carry this I4 term to the left hand side, that means it changes into negative. That means minus 4I2, and we have 1. We have this I2 term which will be plus, and this will give us what? This will give us 6I4. Okay? 6I4. 6I4. So from here, that means if we solve, that means this value will give us, left hand side with 4 minus 1 will give you 3I2, and this will be equal to what? 6I4. Dividing both sides, okay, dividing both sides by 3, we will get I2. Okay, I2 will be equal to what? Will be equal to 2I4. Since we have the negative sign over here, multiplying both sides by minus sign, so we will get this as well as negative 2I4. So this will be, if we know values of I4, then we can find what is the current I2. So let us mark this as one equation. Okay, let us mark this as another equation. Suppose let us put this as equation number 5. Okay, that will be equation number 5. Next, we will try to find out what is, we have determined what is I2. Okay, so from here originally we have this is the current I1, and this is the current I2. We also have that network over here, I3. We will try to find out what is the value of that I3. So how will we find out values of I3? So knowing I2, we can find what? We can find I3. Now over here, see, this is the value of I3. How will you find out this current I3 from here? By substituting on equation number 2. So on equation 2, okay, this is our equation 2. So therefore equation 2 implies this will be value of 1. This will be value of I3. What is the I3? I3 will take this value. Okay? I3 will take this value. 2I2 plus 1 plus I4. 2I2 plus I4. 2I2 plus I4. Then we will use this value of I2. We will use this value of I2 over here to find out how much is I3. So over here, this will be how much? This will be minus 2I4. Okay, plus I4. This will be by using 1. by using this relation number 5. So by using that relation number 5. So when we solve over here, we will find out that this will be minus 4i4, okay, and this will be plus i4. That means over here, after solving, we will get this value to be equal to 1 minus 3i4. This is the value of 1. This is the value of i3. So let us mark this as equation number 6. So let us mark that as equation number 6. So this will be the value. So if we know i4, we can find i2. If we know i4 also, we can find i3. Okay. So if we remember that circuit diagram, we have written this as i1. Part of the current will move across this branch, which is i2, and part of the current also will move across this branch, which is i3. If we know i2 and i3, we can find out what is i1. So our first target is that we should know what is the value of i3. Okay, so when you look from this equation number 4, okay, from this equation number 4, we can find out i1. Okay, i2 we already know. Then we can find out what is the value of i1. Okay, so from that equation 4, therefore 4 implies this will be what? This will be 3. Okay, this will be 3i2 minus i4, and then plus 2. Let's we check again. Plus 2i1. Okay, plus 2i1. So it's better that first we find, see, we have determined what is i2 and i3. Let us find first what is i1. Okay, let us find first what is i1. We can omit this part. Okay, we can omit this part. So first let us find what is the value of i1 from equation 1. Okay, therefore equation 1 implies the value of equation 1 is then i1. Okay, i1 will be equal to how much? i2 plus i3. How much is value of i2? Minus 2i4. And how much is value of i3? Plus minus of 3i4. Okay? Minus of 3i4. So if you solve this one, this will give you minus 4i4 plus into minus will give you minus 3i4. So which means that this value of i1 will give you 3 minus 3 and minus 2, that will give us minus 5i4. Okay, that will give us minus 5i4. Let us mark this as equation number 7 so that it will be simple, so that it will be easier for substituting on that equation number 4. Okay, on that equation number 4. So on equation number 4, so now we can easily substitute on that equation 4. Therefore equation 4 implies, so on that equation 4 we have this expression 3, okay, 3i2, okay, 3i2 minus i4, and then plus, okay, plus 2i1, okay, equal sign 1, equal sign minus 2. So this is from equation 4. That is what we get from equation 4. 3i2 minus i4. Okay, 3i2 minus i4, equation 4. This is equation 4. 3i2 minus i4 plus 2i1 equal 2. Okay, so this is from equation 4. So we will try to solve this part. Okay, we will try to solve this part. Where this is not important. So from here, what is the value of i2? The value of i2 is minus 2i4. That is the value of i2. This is the value of i2. Then we have i4. Then plus 2. What is the value of I1? From equation 7 we have minus 5 I4. Okay, and then this will be equal to 2. Okay, that will be equal to 2. So if you solve this, then you will get this will give you 6 I4. This will give you I4. Plus into minus will give you minus. This will give us 10 I4, and this will be equal to 2. Then see from here, or from whatever complicated steps we have arrived, at this particular step we will arrive by substituting on equation 4. We will arrive at an equation containing only one term, okay, only one unknown, which is I4, I4 and I4. So we can determine this unknown current, which is I4. Okay, so once we know I4, we can easily find out all the currents, respective currents I1, I2 and I3. So from here, if we find out over here, this will be 10 and 6, that means it will give you minus 17, okay, minus 17 I4, and this will give you 2, which means that over here, okay, this current I4 will be equal to 1. This current I4 will be equal to minus 2 divided by 1 divided by 17, and units of current is 1. Units of current will be amperes. So that is our target. Okay, this is our target. So which means that over here, okay, this current will be the current across which branch? Okay, this will be the current across that branch BD. Okay, so this will be along that branch BD. This will be the current along that branch BD. Next, once we know I4, we can easily find out what is I1. So let us find out what is this I1. Okay, therefore first let us find first I2. Okay, I2, what is the value of I2? This will be minus 2 I4. So how much is the value of I4? Value of I4 will be from here, minus 2 divided by 17 from this equation. Okay, 2 divided by 17 from that equation, and then if we solve this, minus to minus will give us plus, so the answer will be 1. So the answer will be 4 divided by 17 amps, amperes. So which means that the current I2, so this current I2 will be 4 divided by 17 amps. That current I2 will be along that branch. If you look from that figure, that current I2 will be along that branch AB. That current I2 will be along that branch AB. Okay, so this is that current. Then next, after finding I2, we will find first I3. Okay, we will find first I3. We will find first what is the value of the current I3. So I3 will be equal to, let's try to recall from there, what is the value of it? Is I3 is minus 3 I4. Okay? I3 is minus 3 I4. So from here, I3 is minus 3 I4. So this will be minus 3. How much is I4 from this equation? Okay, this will be minus 2 divided by 17. So minus to minus will give us plus. So this will give us 1. This will give us 6. Okay? 6 divided by 17 ohms. 6 divided by 17 ohms. So if we know, which means that this value of the current I3 will be equal to 1. 6 divided by 17 amperes. And which means that if we know the value of the current I1 and I2 and I3, we can find I1. If you remember from that circuit diagram, this will be one branch, this will be another branch, this will be that branch, and we have that cell from here. This is the current I2, okay, this is the current I2, this is the current I3, and we have the current I1. Once you know I2 and I3, we can find I1. I1 will be equal to what? I2 plus I3. Okay? I2 plus I3. So therefore, okay, therefore I2 plus I1, okay, I1 will be equal to I2 plus I3. How much is I2? I2 will be equal to 4 divided by 17 plus 6 divided by 17. So preferably this will be equal to what? 10 divided by 17 amps. Okay. This will be for by using what? By using that Kirchoff's current law, okay, which means that this value of I1 will be equal to what? 10 divided by 17 amps. Okay. So this will be the value of I1. We can also use that value of I1 to show whether it is 10 divided by 17 or not. Okay, let us recall that value of I1. How much is the value of I1 from this equation? Look, from this equation also. From that equation, even if we substitute over here also, we should get the same value. Okay, we should get the same value. Let us try to check I1. So this will be minus 5. Okay, minus 5. What is the value of I4? The value of I4 over here, we have solved the value of I4. How much is the value of I4? Let us find from here. The value of 5. Okay, let us first find what is the value of I4. Okay, so this is value of I1, I2, I1, I2, I3, and over here this is the value of I4. I4 will be how much? From here, look from here, this is the value of I4. I4 will be minus 2 divided by 17 amps. From here, if you put that minus 2 divided by 17 amperes, so minus to minus will give you plus, 5 to 2 will give you 1. 10 divided by 17 amperes, which means we got the same result, which means that I1 will be equal to 1. 10 divided by 17 amps. 10 divided by 17 amps. If you look at the final result also, we get I1 is 10 by 17. Look over here, I1 is 10 by 17. If you solve from here also, we get I1 to be equal to 10 by 17, which means that you have got all those currents. Okay, so wait, in your exams you have to mention this will be current along that branch. Okay, this is I3 will be along branch 1. This is branch AB, then you have C, then you have D, then this will be along this I3 will be along what? Will be along branch AD. Then this I2 will be along branch AB. Okay, and this I1 will be the main current, the current in the main circuit, the current in the main circuit, and that current I4 will be given by that equation. Okay, this is the current along branch BD, which is minus 2 by 17. So that is the way how to solve these problems during your examination time. So just focus and review again so that you will get a clear clarity. Thank you.